It's great to be here. I'm so glad to be able to share with you the definitive deep dive into the .git folder. We're going to talk about a lot of things around Git and take a look at each file inside the .git folder. Now, we're not going to run all of the Git commands, but we will see all the files in the Git folder and get to experience how each of them work. Hopefully that makes Git a little bit less mysterious. So let's dive in. Now, here we're going to talk about all of the different pieces inside the .git folder. Here's the part where I tell you I am definitely going to present my slides on my site tonight. But in this case, there are no slides. Now, we will talk about a lot of different websites. So I did prepare a gist here that identifies each of the files that we're going to look at. Now, this URL is a little bit long, but you can come to robrich.org, click on presentations, and here at the top is the definitive deep dive into the .git folder. And here's the link straight to that gist. Now, while we're here on robrich.org, let's learn about some of the things that I've done recently. We'll click on About Me. I'm a Cyril developer advocate. If you're struggling with your data mesh, I would love to learn from you. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp near you, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. We talked about some of the other things. Thanks for the introduction. Here's the SQL source control basics. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame. So let's dig into all things Git. I have an empty folder here, and our job is to create a Git repository. Now, there's a couple of ways that we could do that. We could say git clone and pass in a URL, github.com. But in this case, let's not do that. Let's say git init. Now that's going to create an empty folder here inside Git. And so here's our .git folder. Now I've chosen to show hidden files, which is why I see it by default. But if not, you can come here into the view options and you can choose to show hidden files. Now we're going to take a look at everything inside this .git folder. So I'm going to very specifically open up the .git folder in VS Code rather than opening up the host folder, the outside folder. Now that we've got this Git folder open here, we can see that we've got hooks, we've got info, objects, all of these are empty. We've got refs, we've got some config here, a description. Let's take a look at each of those things. Well, right now we have a pretty much empty folder. So let's create a commit. I'm going to say echo file1 contents and redirect that to file1.txt. Okay, now let's git add file1.txt and let's commit it. Git commit -m and I'll say file1 commit message. And now we've committed that. If I say git log, we can see that there's my commit. It has this hash 8A95C69. Now let's pop back open into the .git folder. Ooh, we have a whole bunch more content here in our objects folder. Now 8.9, that's the beginning of our commit. 9.5C9, here is the contents of our commit. Now it is a zlib compressed file, so it doesn't mean a whole lot here in text format. So let's unzip it. Now, there's a couple of different ways that we can unzip it. We could use a Perl script. We could use OpenSSL, kind of an interesting use of OpenSSL, all else being equal. A Python script. In my case, I chose to write this unzipper program. And this unzipper program will just open up the file and use zlib.inflate to just show the content. I'm splitting by nulls just so that we can see all of the content. Okay, so let's do this. Unzipper.git/objects/89/84/8A. Actually, let me go find what that was. Git log. There we go. 8A. Unzipper.git/objects/8A. And here is the contents of that file once we zlib uncompress it. Now here's the number of bytes in the commit message. So that's the number of bytes here. We've got this tree. It is of type commit. That's interesting. And it references this commit. Okay, so let's unzipper that one. .git slash objects slash 7.2. And here's the contents of that. Well, it's zlib compressed in a very different way, but it is a tree node. And what is the third one that we have? 8.4. Let's unzipper that one. So let's unzipper 8.4, and here's the contents of that. Now we see this one's a commit, this one's a tree, and this one's a blob. That's kind of cool. We can use git commands to be able to read these, and so let's see if we can do that. Git cat file -t, and we'll look for 8a95c, and yep, it's of type commit. -t will give us the type, or we can do -p for the contents. So that one references this tree node. Let's do the same thing here. Git cat file -t. Yep, that is a tree node. Let's do the contents of it. And we've got this reference to this blob node. Let's do a cat file to this blob node. And we can see that that's the contents of our file. Oh, that was pretty cool. Let's do that again. Echo file2. We will redirect that to file2.txt. Git add file2. Git commit -m file2. And now we have a new commit, this 339608. So we could git cat file -p, that one, and that references this tree node. It also references this parent node. Wouldn't it be cool if we could kind of visualize all of this content without having to git cat file all of the things? I wrote this program that allows us to be able to visualize a tree in an interesting way. So I'll specify the path to this repository, and let's start up this program. Now, the cool part about this program is it will now take a look at that commit and the commit history, and allow us to see not only the commit nodes, but also the tree nodes and the blob nodes. So if we've got our content fired up, there we go. So there's our 6 nodes, and we can click on each one to kind of take a look at what this is. This one is a tree node. This one is a commit node. Let's show the type, and I just randomly picked colors so that we can see it. And let's maybe put it in alphabetical order and show the tags. So now we can kind of easily browse through the things. Now, it's still not really apparent which one is which, but we know that this is our current commit, and it references this tree node 2b0, so that one. And it references these 2 files in the tree node, file 1 and file 2. Okay, so here's file 1 and here's file 2. Now, wouldn't it be cool if we could maybe put it in parent-child order? Let's show the lines, let's show the tags, and now we can see that there's our commit node, and it references this previous commit. This previous commit has this tree node that only has 1 file in it, where this commit has 2 files in its tree node. This file, here's file 2, and also this file, here's file 1. That's pretty cool. Now, how did these files come to be? Let's take a look. We now only have our 6 nodes again. So let's start to commit some content. Echo file3, and we'll redirect that to file3.txt. We haven't done any git commands yet, so no changes there. Git add file3. Now let's come back to this and refresh it and see if we got any new content. Yep, we now have 7 nodes. Show the type, parent child, show the lines, show the tags. Ooh, we have a new file. As we add a thing to the staging area, it creates a new file that has no reference to any commit. We haven't committed it yet. That makes sense. So let's commit it. Git commit -m file3. And now we've committed it. So let's come back in here, refresh. I'll show the type, parent child, show the lines, show the tags. Yes, now we have this commit with the commit message of file 3. It references this tree node that has the 3 files in it. And as we take a look at this, we can see that here's file 3, file 2, and file 1. Now we don't need duplicate copies of these files, even though we're referencing it for multiple commits. The files haven't changed. Let's do that again. Now in this case, I'm going to say, let's create a new folder, mkdir folder, and let's echo file 2 into folder/file2.txt. Okay, now I have a new file here, this folder. So let's git add folder/file2, git status. Okay, so that's in the staging area. git commit-m file 2 in a folder, and let's take a look at what we see. Now, if we refresh this, we now have 4 commits. This one references these 3 files in the current directory and this folder. Now, this folder has file 2 in it and nothing else. But notice how this references the same file 2. We only have 3 blobs. We only have 3 unique files, so that totally makes sense. Okay, let's do that one more time. Now, in this case, I'm going to say echo file 4 to file 4.txt. And now, I'm messing around here in file 4, and I accidentally added some secrets. Secrets here by accident. More content in file 4. This is another line. Now let's commit this. Git add file 4, git commit-m file 4. Oh, hey, now as I'm cruising through my history, I see that I accidentally committed this file that includes these secrets. Uh-oh, how do I get these secrets back out? Okay, so I'm just gonna come in here and, not that one, come in here and let's open up file 4 and let's remove the secret. Okay, I think I'm saving my bacon here. Now let's say git add file 4, git commit-m file 4, and I actually learned about this amend command, and that will not only commit it, but also change the previous commit. Oops, I don't know how to spell amend. There we go. And so that actually said, if I say git log, I only see this one file 4 commit, git log --one line --graph --decorate --all, and I don't have that content here at all. That's great. Let's refresh. Show type, parent child, show the lines, show the tags. Oh, I have this new commit that references this file that doesn't have my secrets in it, but I still also have this commit that does have my secrets in it. The moment that you commit secrets into Git, you should consider them as lost. Even if you rewrite your history, even if you change your content, that content is here in Git, and eventually it'll go away, but not for a good long time. So we got to see a lot of content here in the objects folder, and in time, if we pack this, then that will end up in this pack folder. Now I'm not going to do that, but behind the scenes, Git will run git gc periodically, and so sometimes you might notice that some Git commands take a little bit extra time, and that's Git going and arranging all of these files inside the objects folder and packing them into a pack file in the pack folder. Next up, let's take a look at branches. So when I said git log --one line --graph --decorate, I now see this head points to main. Now head represents my current checkout directory, so we can see there's my checkout files. But what is main? Well, I noticed there's a head file right here. Let's open up head, and it says refs heads main. Oh, here's a refs folder. Oh, there's a heads folder inside of it. Let's take a look at main. Main says it points to 162.44125. That happens to be this commit. So basically, main is just a text file pointing at the commit. Well, what if we said I wanted it to be this commit? So let's go grab this git hash and let's put this here. The only way you can break Git is by changing the contents in the Git directory. So if we one line graph decorate, we now see that we've moved head or moved main. Now, let's definitely not do that. That's not the way you want to move branches, but that's how this works. Okay, so let's do this. Git checkout 339608. Ooh, we are in a detached head state. So like I took off my head. Now, what does this mean? It says it's in a detached head state, and we can see that we're pointing at a particular commit. If I open up head, it no longer points at a branch, it points directly at a commit. Now, that says to me that if I'm cruising around here, I can still add files, echo file 5 to file 5.txt, git add file 5, git commit -m file 5, I can still commit content, but if I do this git log --one line --graph --decorate all, we can see that head is now wandering over here. If I say git checkout main, well, now there's nothing pointing at that other thing. What it said when I had that detached head is, hey, your branch points to nothing. You need to go check out a folder. Okay, so let's check out a folder. Git branch, new branch, and I'll put it here on file 2. And now we've got this new branch right here. Popping open our refs folder, we can see that we have this new branch file that points at this new commit. Now head still points at main, but if we were to check out, to git checkout new branch, we can see that head now points at new branch. Okay, that was pretty cool. Now what about remotes? I have here another folder that is another empty folder. Let's create this as a server, git init. Last time we just did git init, but because it's a server, I'm going to say --bear. Now when I say --bear, it doesn't create a .git folder, but rather only the contents of the .git folder. That's perfect for a server. So here, let's say git remote add origin. What is origin? Just the name that we gave it. Now I could give it an HTTPS URL to GitHub, or I could give it a path to server and folder, or I could give it c:/some folder. In this case, I'm just going to give it the relative path up to that server folder. Now that I have this remote, I can say git push origin main. Now this always felt backwards to me. Why wouldn't I say git push main to origin? Well, I could push main, and I could also push new branch. And so the first thing is where I'm going to push it, and then the rest of them are all of those branch names. So we can now see here in the server folder, in our objects folder, we have all of those objects that we passed from our checkout directory into the server. Back in our checkout directory, we now have a remotes folder. Now inside remotes, we have an origin folder, and we now have references to where the last place that we saw this server. That's great. Next, let's take a look at tags. So I can say git tag v1.0 or 1.0, and I'm going to attach this to main. So now if I'm looking at my content, I can say, okay, so there's a tag. And back in my .git folder, I now have this tag pointing at this particular commit. Everything inside the refs folder is pointers to where we have our content. They're human readable labels to that. That's really cool. Now, whether we're using remotes or whether we're using tags or branches, they're just files inside this refs folder. Now, remember that commit that we lost a bit ago? How can we get that back? Well, let's take a look at ref log. So I can say git ref log, and it will show me where I was in all of these commits. Now, I wanted to commit this one to a branch. So let's say git checkout that commit, git checkout that commit. And now we're back to that branch. But now if I do the reference, I can now get back to exactly where I am. Let's git checkout -b other branch. And now that commit is safe. Reflog is a good way to be able to discover those remote sessions. Now here inside logs, we have refs, and we have a ref log for each of our branches. Here's where main has been. Here's where head has been. It was here and it moved to here. It was here. Here's the details about that. And so even when we created this commit that we didn't want anymore, it's still in our ref log. We can still get back to it. Now in time, Git will clean up after this, but that's where ref log can be really helpful. So we took a look at objects, we took a look at refs, we took a look at these logs. Next, let's take a look at hooks. Now here inside hooks, we have these .sample files. Here's a shell script, here's another shell script, here's a Perl file. Now I'm going to copy in some files that come from, that don't have the .sample in there. Let's just set this into place. Now these ones without the .sample are just shell scripts, and I've just output the arguments passed to it. So now let's do a commit. Echo file 6, and we'll redirect that to file 6.txt. No git hooks yet, git add file 6. No git hooks there, git commit -m file 6. And now we'll see a bunch of hooks. Now we could use these hooks to automate interesting things like linting our process or running unit tests. And so we can see a pre-commit hook, a prepare commit message hook, commit message hook. We also get the file that that content came in on. That's pretty cool. Now if we say git push origin other branch, we'll see some more hooks, a pre-push hook. If you've ever used Kudu to push to Azure, and you do a push and then a whole bunch of things happen, there's a commit hook on the server responding to this content. Now, I've got these hooks the way I want, so let me git add.git/hooks/ pre-commit hook, git status. We can't commit content inside the .git folder, but we can use various packages to be able to get content out of the .git folder. So for example, here's git hooks. Once we install git hooks, it will create symlinks into a .git hooks directory that allows us to now commit our hooks into our source control system. As you grab this list from this gist, here's other programs that can use Git hooks in various languages. Hooks can be really excellent at being able to automate tasks that we might want to do. Next, let's take a look at exclude. Now, this is one of the config files. We could use this to exclude bin and obj files if we were in .NET, node modules if we were in Node, the .vn folder if we were in Python. Now, we could exclude files here, but once again, we can't commit this directory. So let's not do it here, but rather let's do it here. Echo bin into .gitignore. Now, if we put it in a .gitignore file outside of our .git folder, now we can commit it to our repository. So for example, I can put in all of the files that I want to ignore, and now I can commit that. Git status, git add.gitignore, git commit -m, add git ignore file. Now I can share it with others. Perfect. Now there is one inside the .git folder, this exclude file, but all else being equal, I would invite you to not use it and use a .gitignore file instead. Next, let's take a look at config. Now here's a config file that specifies the details associated with this particular project. Now it is it overrides the content inside of my, I'm gonna have to open it. Open file, see users, rob.git config. It overrides the content here in my user specific git config file, which, pardon me, overrides the content here in my git config file, program files, git, etc config, nope, user, etc, nope, user config. Oh, I can never find this one. Lib, user, lib, config. Nope, I'm gonna give up. Anyway, that one is the machine specific git config, the one I can't find. This one is the user specific git config that overrides it. And then I have a local one specific to my repository. Now, remember when you first installed Git and you did -- global? That's setting these things, my name and email address inside my Git config file. Well, what if I have some work projects and some personal projects? Well, I can take this configuration and I can copy it into my local config file, and I can change this to be business.com. Now, business. Now, a lot of my content will go to my personal account, but this particular repository will be for my corporate account. Now that's perfect. We can override any of the settings. So for example, if somebody installed their Git but didn't do auto CRLF, we could come in here and we could say, this actually needs to be false. And remember when we created the bear repository for the server? This would be true. Now, in this case, we're not going to do that. We're just going to leave it. But another really cool thing here in these Git configs is aliases. So for example, have you ever done this where you start typing Git and then you're off doing something else and you get distracted and then you say Git status? Well, I happen to have an alias that will take Git as a command and run that Git command with it. So if I say Git status, then it works really well. Now, I actually accidentally used this command, which is the help autocorrect. And so it will automatically run that command, even though I spelled it wrong. So we're doing great. We took a look at config files. This description file is the description for the website if you're using the Git web server. Now, we probably don't use the web server built into Git. We probably use something like GitHub or GitLab or Bitbucket. But yeah, there's a web server built into Git, and this is the description for it. One more file that we want to look at is this index file. Now, it is a binary file, and so it's a global mess here. Let's take a look at what is in there. Now, here in this Git index file is all of the different files in our working directory. Now we can see this is the format for those files, and it is a bit involved, but we can use this git command to just take a look at it. Now, if I run this git command, I can see that these are the files in my working directory, and here's the git hash of the last time I committed. Why does git status work so fast? Because it compares the hash of each file in my working directory together with the hash in this index file. If you really want to parse this index file without Git tools, then you can use this program. It's called Gin, and it works pretty well at parsing this file. All else being equal, I'm going to lean on the Git ls files for this though. Now we got to see a lot of different things. We got to see configuration files, both with our local config and the system config in our user profile and the machine config. We got to see the index file that allows us to do Git status really fast. We got to see hooks that allows us to do automation really easily. We got to see the logs, the ref logs that allow us to find commits inside of our refs folder that we may have abandoned. We got to see refs, how it stores the different details, branches, both branches and tags and remotes. We got to see the objects that allow us to be able to store all the content inside of Git. Now, these are all of the files inside the .git folder. We haven't run all the Git commands, but hopefully this demystifies Git in some ways. A great resource to be able to continue on with this learning is this blog post that I'll link in the gist that describes each of those files and what they do. You can grab this from this gist with links to all of the tools that we took a look at, and that is available on robrich.org. Click on presentations and you can get straight there. Thanks for learning the definitive deep dive with Git into the .git folder with us. You can grab me on Twitter at Rob_Rich. If you're watching this video later, I look forward to your thoughts there on Twitter. Grab this content from robrich.org/presentations, and I look forward to your questions. What are your thoughts?
Thank you very much, Rob. Okay, so we have the first question coming in, asked by Pranav. What is data compression? Is it something like gzip or deflate, or is it something else?
That's a great question. What is that zip format? It's actually zlib compressed. And so if you use the zlib library, you can be able to decompress that content inside the objects folder. Great question.
Understood. So I would like to ask one question based on, actually before that, let me share what Pranav is saying, that his question was about data compression, the thing that's used to upload to server.
Oh, that's interesting. Yeah, those zlib compressed blobs are what is sent between client and server. Now, part of what makes it so efficient is we can just start in our trees and work our way down until we have a git commit that is the same. Once we have a git commit with the same hash, we know that all of the content from here down is the same. So we don't need to send that again. Once we've found that common commit, then we'll only push those blobs, those zlib compressed objects to the server. And it's just passing in those same zlib compressed details. It's not any different from how it stores it to how it pushes it over the network.
How do people utilize this knowledge? Or you might have shared this before with other people, how they have used this information in their day-to-day life as a developer.
One of the things that a lot of people struggle with is, why do I have this staging area? Why can't I just commit it? Why do I need to commit it and then push it? Why are these concepts separate? And so what I hope to pass along as I share all of the details inside of the .git folder is, here's kind of how Git works under the hood. So from there, you ought to be able to approach the command line and say, yeah, I understand that I'm going to add something to the staging area. It's going to create a blob inside my objects folder. So now I'm able to commit part of the file, or commit this file but not that file. It's adding those blobs into my commit history. I can also do some interesting automation with Git hooks. I can say, I usually forget to run my unit tests before I commit. So let me create a pre-commit hook that will run all the tests, or maybe my linting program, on all those files that I've just recently staged. Those are things where this knowledge of how Git works under the hood should make it a little bit easier. It's not quite so mystical. Now, I know you probably have a few Git commands taped to the back of your keyboard, but hopefully you can get past that and kind of take advantage of some of the power of Git. I hope by showing you how it works under the hood, it's also a little bit less scary. Unless you change something in the .git folder, you really can't break it.
That answers my question. The fear I have about the .git folder, and the hooks. I think I have used hooks a lot, and I think this has given me a whole new perspective how things are happening under the hood, and I'm more confident about dealing with even complex command, or even understanding that or visualizing how things are happening in the Git. So we have one more question, which is about the application. They're asking that which application did you use to show that tree-like structure in some UIs?
That is a great question. That is a program that I wrote called Git Explorer. You can get to it from the gist that I showed. Git Explorer is one of the top links there. And it's a program that opens up each of those objects and unzlib compresses it to be able to show it on screen. If Git Explorer is really helpful to you, I would invite you to fork the project or download it and fire it up on your solution. It should work on solutions big and small. Now, in the majority of cases, we really only care about the commits, not the tree nodes and the blobs. But it is kind of nice to be able to visualize what's happening under the hood. So I went looking for a tool like this. I couldn't find it, so I wrote one.
Got it. Understood. What would you suggest for people? Let's say we have different people in the audience, like people who are just beginner with Git, also people who are kind of at advanced level of Git. They know most of the commands that we use for development workflow. So from here on, what are the resources that these two kind of people can check out after this talk that will help them build better understanding and make them more productive developer?
Great question. And that is great. How do we go farther than this talk? I have collected all of the resources here in this gist so that you can start to review the content. And as you think about it, maybe tomorrow or next week, hey, what was that folder in the .git folder for? Reference that gist that will help you find the tools and links that we found. How do you go further? I really like to start experimenting. So find a project that you want to move to Git, or find a command that you want to experiment with Git, and take out the Git Explorer for a tour and see if you can understand some of how those objects are moving throughout Git as you do things. It could be really cool to be able to dig into it. If you find a smaller project, maybe a hobby project where the risk is really low, then maybe start playing with the config file and adding aliases or various shortcuts. And that might be really helpful in starting to explore some of the power of Git. As you get more comfortable, then you may wander into things like Git bisect or rebase and start to really take advantage of the rich power that is in Git. There is a lot of really nifty tools inside Git. So I hope that you'll be a little bit less scared to take advantage of exploring some of these and starting to expand your horizons.
God,
Sounds great. Thanks for having me on. This was a lot of fun.
Yeah, same here.